Why does partial pressure affect sublimation? Imagine a block of dry ice slowly turning into gas without melting into liquid first. What makes this happen? The answer lies in the relationship between vapor pressure and partial pressure. When a solid like dry ice sublimates, it turns directly into gas. But this process depends on the environment around it. The vapor pressure of the solid is how much its molecules want to escape into the air at a certain temperature. Partial pressure is the pressure exerted by the vapor of that solid within a mixture of gases. If the partial pressure of the vapor in the air is low, molecules can escape from the solid easily. This means sublimation happens faster because there are fewer vapor molecules above the solid to push back. Now, if the partial pressure is high, many vapor molecules are already present. These molecules bump into each other and can reattach to the solid surface, slowing down or stopping the sublimation process. Think of it like a crowded room where it's hard for new people to enter because it's already full. Each solid has a specific vapor pressure at each temperature, which tells us how eager its molecules are to escape. When the vapor pressure of the solid matches the partial pressure of its vapor in the environment, the system reaches a kind of balance. If the environment has a low partial pressure, sublimation can happen at lower temperatures because the vapor pressure of the solid doesn't need to be very high to match it. That's why in a vacuum, substances like dry ice can sublime at much lower temperatures. This is also why vacuum sublimation is used to purify heat-sensitive compounds. On the flip side, increasing the partial pressure of the vapor in the surrounding gases makes it harder for the solid to turn into gas. More vapor molecules near the surface mean more chances for molecules to collide and reattach, reducing the net rate of sublimation. This also affects the temperature of the solid during sublimation, often stabilizing it at a certain point. From a thermodynamic point of view, sublimation depends on the balance between the vapor pressure of the solid and the partial pressure of its vapor in the environment. The closer these two pressures are, the slower the sublimation becomes because the system is nearing equilibrium. This principle is used in many practical processes. For example, freeze-drying removes water from materials by lowering the pressure, allowing ice to turn directly into vapor at low temperatures. Similarly, in chemical purification, controlling the partial pressure helps selectively sublime certain compounds while leaving impurities behind. So, in simple terms, partial pressure controls how fast or slow sublimation happens because it influences the pressure difference that drives molecules from the solid into the gas phase. When the partial pressure is low, sublimation speeds up. When it's high, it slows down. This relationship is a key part of understanding how phase changes work in thermodynamic systems.